Welcome back. This is lesson 4 of week 7. We've done quite a lot of work with truth tables and logic circuits and expressions. And in this lesson, we're going to look at some more complicated examples of deriving truth tables from logic circuits. So in this lesson, we'll go through a worked example and then I'll set you several challenges of increasing complexity. This is the example we're going to go through. Remember the method, label all the intermediate points and then create a truth table with a row for each possible combination of input values. So here are all the intermediate values, and now we've got to create a truth table for values of A, B and C. So that would be the same as the binary numbers from 0 to 7. Expand the table to include all the outputs, all the intermediate values as well as Q. And then as we fill in the truth table, for each of the letters we think, what type of gate is it? What are the two inputs to the gate? And we note that expression at the top of the column. So for example, output D, what is the gate and what are the two inputs to the gate? So D is A and B. So to complete that, we look at the values of A and B, and D is only true if both A and B, and D is only true if both A and B are true. Then we'll do the same for E, F and G. What are the gates? What are the inputs to each gate? So writing that all in and completing the values. So that's the method. You've already learned that method. Let's look at some further examples. This one you've already done. So create a, that's a logic circuit. Create a truth table to match that. Exercise 2, this is new. It's a 2-input truth table with intermediate points. It uses and, or, and not. And this is the third one I'm leaving you. This is a more difficult one because it's got 4 inputs. And remember, that means there are 16 rows to the table. So it's, I would say, more difficult than you're likely to see in the exam. And exercise 4 is a challenging one because it's only got 3 inputs, but it's got a lot of gates. So see if you can create a logic table to match that. These complicated ones are more difficult than you'll see in the exam, but if you can complete them, you can be confident that you've really learned the subject. For further practice, you can create logical expressions to match these circuits. And in many cases, it may be clear to you that we could simplify these circuits and create much simpler circuits that do the same job. This is actually what we'll be looking at in week 8. So if you can get ahead of the curve, that'll be really handy. Okay, I'll see you in week 8. Bye for now.